In this video, I'm going to cover comparison operators and basic if statements. And when I say basic, it doesn't mean something like so easy that you never use it. I just mean I'm not going to do the compound if statements with if, else, elif, those kinds of things. If you don't know what those things are, don't worry, we will learn those in a future video, but we're going to just focus on comparison operators and building if statements out of those. When I say comparison operators, it sounds like a big word, but it's really a concept you're very familiar with. The less than symbol we'll start with. So I'm just going to type the less than symbol here. We know this from math. We can say 3 is less than 5, 4 is bigger than 2, that kind of thing. If I type 3 is less than 5 into Python, and for now we're just going to see what the result of doing the comparison operators are, and then we'll put them into the if statements. So I type 3 is less than 5, and it tells me true. So it's going to give me a true or a false based on whether or not the comparison is actually valid or not. So if I tried doing 5 is less than 3, that's not real. So that's going to give me a false. So we have the less than operator, we have the greater than operator. If I said 5 is bigger than 3, we get a true. If I say 4 is bigger than 88, we're going to get a false. If you think about some of the comparisons you've learned from basic math, you would have learned less than, greater than, less than or equal, greater than or equal, and equal. Those would be the main comparisons. If we want to do less than or equal, we don't have a symbol on our keyboard that looks like the symbol that you write for less than or equal on the page in math. So if I wanted to say, oh, is 5 less than or equal to 5? It's true, because it's equal. The way that I write this is I write a less than sign and an equal sign. So it kind of looks like a little arrow, but you want to just break it up and not see it as an arrow, but see it as a less than sign, then an equal sign. And of course 5 is less than or equal to 5 because they're equal. And then of course we can do the same thing with greater than. 88 is bigger than or equal to 8. This is going to be true as well. So I know that these statements seem a little bit obvious. You know how to compare numbers, and you might be thinking like, why on earth would I need to do something like this when I'm doing programming? So I'm going to just introduce a variable. Maybe, you have a couple of people and one person is 17 and the other person is 44 years old. And you're a bouncer at a bar, so you can only let someone in if they're at least 21. What you want to do is, to represent this on the keyboard, we would say, okay, is age of person 1 bigger than or equal to 21? And if they are, then we let them in. You might have a website that you go to, and they also might have an age restriction of 21 if they're maybe selling whiskey or something that requires you to be a certain age. If you go to a website and they have you enter your age to decide if they're going to let you proceed to the website, they're going to take your age as a variable, so like age person 1, age of person 2, and then they're going to see if how that compares to 21, if it's bigger than or equal to, or if it's less than. So these operators come in handy, especially when we have variables that will, change depending on the circumstances in the program, so that we can have the computer make decisions when the program is executing. That's why I'm writing these very obvious statements. 4 is less than or equal to 4 and getting true. But this is just to show you how the syntax for this works, so that we can then build statements that are going to make more advanced decisions for our program. These are 4 of our basic comparison operators: greater than, less than, greater than or equal to, less than or equal to. The last one we have is equals, and it's not tricky, but it messes people up a little bit. If I were to want to see if the number 5 were to equal the number 5, again, we would have variables probably representing quantities and seeing if they're the same. If I want to see if 5 equals 5, I have to type a double equals if I'm comparing them to see if they're the same. So if I do 5 equals 5, it's going to give me true. If I did 5 equals 5, like this, it's going to mess up the computer because it thinks I'm trying to change or set this value equal to something else. Like it thinks I'm trying to treat this like a variable. Because you can see above where I set variables, I did the variable name equals and then a number. So this is called assignment of a variable. You're assigning a value. And here, if I do 5 equals 5, it gets confused because it thinks I'm trying to do assignment, and you can't assign a value to a number because the number is just the number that it is. So it'll give you an error. I guess the trickier trap that some people fall into is maybe you want to see if the person, so age of person 1, you want to see if they are 18 years old. Some people will type age person 1 equals 18 to see if the person is 18, asking for a true or a false. But the problem is that if I do this, what I have done is I've reassigned the value of age person 1 to be equal to 18. So the single equals always does assignment, while the double equals does comparison. So I just reset age person 1 back to 17. And now if I want to do this correctly, if I want to say, okay, is person 1 equal 18 years old, I would say age person 1 equals 18. And we know they're 17, so they're not 18. And therefore we get a false. So just be very careful with that equals versus double equals, because sometimes it'll give you an error and just stop the program. And that's kind of nice actually, because then you know where the problem is. But sometimes if you forget the second equal sign and you're doing like a comparison between a variable and a number, that can really confuse your program, and then it's a little harder for you to trace back to like where the error is. We can use 2 variables if we want to in any of these comparisons. So I could say age of person 1 is that less than age of person 2, and that's true. Is the age of person 1 bigger than or equal to age of person 2? False. So we can compare quantities in whatever form they are in. If they're variables, if they're just in regular numbers, whatever, we can use these comparison operators as long as we're comparing the same type. One of the things that is often overlooked until you see it is that we can use these comparison operators on strings as well. So maybe like person 1 equals, maybe the first person who walks into the room is named Amy. Person 2 is Kyra. Person 3 is Louise. And person 4 is Caden. Okay. Nope. That gave me an error because I didn't close the quotes. That's okay. So person 1 is Amy, person 2 Kyra, person 3 Louise, person 4 is Caden. I had to do that down here because I messed it up. And whenever you're doing a string, so like any words or sentences, whatever, you always have to put them in quotes so Python knows to keep the whole thing together. I could even do something like person 5 equals Sally Ann, and as long as it's in quotes, P5 will be the whole string Sally Ann, and then maybe after a little bit of time, another Kyra enters. So now, say I have 2 people and I want to know if they have the same name. I might say, okay, does person 1 have the same name as person 6? And that's false. Person 1 is Amy, person 6 is Kyra. But then I could say, does person 2 have the same name as person 6? And that's true because person 2 and person 6 are both Kyra. So the point of this is that we can use equals equals on, it doesn't have to be just numbers. We can use it to compare strings. We can use it to compare individual characters. We can also weirdly use less than or equal, less than, greater than or equal, and greater than on strings. So I'm going to type in a few examples. I'll just do P1 versus P2. So P1 less than P2. P1 bigger than P2. P3 less than or equal to P4. And P3 greater than or equal to P4. So I'm comparing strings, and it's telling me that certain things are less than or greater than other strings. And it's actually useful when we understand how this works. So the way that this works is that it's doing alphabetical order. So P1, which is Amy, comes earlier in the alphabet than Kyra. So Amy and Kyra are going to have the property that Amy is less than Kyra. So things that are earlier in the alphabet are less than things later in the alphabet. It is important that if you're doing anything with alphabetizing, you do have to make sure all of the words being compared either all start with capital letters or all start with lowercase letters, because eventually you'll learn more about ASCII tables, but you'll see that capital A has a different numerical value than lowercase a. The moral of the story is that we always want them to have the same capitalization if we're going to compare words for where they fall alphabetically. Back to these, P1 less than P2, that's true because Amy comes before Kyra. P1 bigger than P2, that's false because Amy does not come after Kyra. P3 less than or equal to P4, that's false. So this tells us that P4 is going to be earlier in the alphabet than P3. We have P4 is Caden, P3 is Louise, K comes before L, so it makes sense that P3 less than or equal to P4 is false. If I say P3 is bigger than or equal to P4, basically saying P3 comes later in the alphabet than P4, or that they're the same, I get true. Again, we know P2 and P6 are the same, so if I do P2 bigger than or equal to P6, we're still going to get a true because they're equal, and this, will work for bigger than or equal. So this is a nice little trick about strings. There's a lot of examples. I won't go into all of them. All right, so these are our 5 basic comparison operators: less than or equal, greater than or equal, or equivalence, which is denoted by equals equals. So how do we use these in if statements? Well, earlier I did an example of, there's a person and their age is 30, and another person and they're 7 years old. And now let's say I have some sort of situation where you must be under 13 to play on the slide. Remember, if I put something after this hashtag, it's just a comment. It means it doesn't affect what happens in the code. It's just some words to read for my reference. Maybe there's a requirement you have to be under 13 to play on the slide. So we might have a if statement to decide if someone gets to go in or not. Something like if age is less than 13, print you can go play. So this is what this is doing, is this is creating our first basic if statement. If statements, kind of think about them as having 4 parts. So we have an if, then we have a condition, something that's going to evaluate to true or false, like age 1 less than 13 is going to evaluate to false because age 1 is 30. And then we have a colon. You always have to have the colon in here. And then underneath the if statement, you're going to have things that you want to have happen if the condition is true. And in order to group together anything that we want to have happen, we have to have it indented 4 spaces. If it's not indented, it won't be viewed by Python as being part of the if statement. So I can say print you can go play, I can say print have fun, and both of these are indented, so they're both going to happen if the age is less than 13. Now, this is what we do if someone is less than 13, but if someone is older than or equal to 13, then we'll say print you are not allowed inside. If age 1 is bigger than or equal to 13, we can print you're not allowed inside the slide. So here we have 2 if statements. The first one this will happen if the person is under 13, which they aren't, age 1 is not. The second one has age 1 bigger than or equal to 13, so this is what will happen because age 1 is bigger than or equal to 13, and it'll print you are not allowed inside of the slide. So the first block of code never happens because this condition, age 1 less than 13, is false. The second block of code will be evaluated because age 1 bigger than or equal to 13 is true. So I'm going to hit enter, and you will see that it gives me the result. You are not allowed inside the slide. Now I can change this and have this tweaked for the other person, the person who is 7. So we'll put age 2 in instead as our variable. Of course, they are less than 13, so the first block of code is going to be executed where they're going to be told you can go play, have fun. And if I hit enter, it gets evaluated and it says you can go play, have fun. So the code under the if statement only ever gets run if the conditional is true. So I just want to, now that we're here, this is the stuff that I wanted to cover in this video. There's more that we can build on later, but I want to make sure that the syntax and like the formatting for an if statement is clear. We always have an if. We always have a conditional. This is something that's going to evaluate to true or false. We put a colon here, and then everything that's indented on the lines following the colon is going to be what happens if the conditional is true. If the conditional is false, none of the indented code runs. So there you have it. I'll see you in the next video.